can you solve this geometry challenge? Here's the question. Given this rectangle, draw point P outside of this rectangle, then connect this point P to the vertices of the rectangle, and it creates two triangles. Now, the area of this blue triangle must be equal to 30 square units, while the area of this green triangle must be equal to 10 square units. Now, the question is, what is the area of this rectangle? Now, you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so at first it looks like it is impossible to solve, but this question is solvable. To answer this question, let's extend the side of this rectangle directly below the point P. Now what we're going to do is to draw a perpendicular line through point P that intersect to the extended side of this rectangle. Now, what we're going to do is to use the concept of the area of a triangle, because we know that the area of a triangle must be equal to 1/2 multiplied by the base times the height. So whatever the base, multiply its height, multiply by 1/2, and that is the area of a triangle. Now, let's have this one. Let's say, for example, this side right here must be the base of this triangle, the green triangle rather. And this must be the height. Alright, now if we move this point along in this line, we get a lot of triangles with the same area. The reason is we have the same base and the same height. So what we're going to do is to move this point right about here. So this triangle also have an area of 10 square units. The reason is we have the same base and we have the same height. Alright, so now let's do this to the blue triangle. Alright, so let's have the base and the height. Now again, if we move this point P along this line, we get a lot of triangles with the same area. So like this. So we will put this point down right here. Now all of these triangles have the same area of 30 square units. Alright, and then what we're going to do is to focus on this figure. And then let's name the rectangle that we want to find the area. So let's call this rectangle as ABCD. So rectangle ABCD, this is the area that we want to find. Now this point right here, let's call this as E, and let's call this vertex as F. Next, using again the concept of the area of a triangle, what we're going to do is to this point, we need to move this point along in this line. So again, we create a lot of triangle with the same area of 30 square units, like this. Alright, so all of these triangles have the same area of 30 square units because of this connection of the base and the height. Alright, now let's put this point right about here. Next, let's focus on this rectangle BEFC. Now notice that half of this area must be equal to 10 square units. So what we're going to do is to flip this region like this, and we know half of this rectangle also measures 10 square units. Now, here's the good thing. This 30 can be divided into 2. We have 20 plus 10. So, we know also that the region right here is 10 square units. Therefore, half of this rectangle, or the area of half the rectangle ABCD, must be equal to 20 square units. So the other half measures 20 square units also. So the area of this rectangle ABCD must be equal to 20 plus 20, and this will give us a value, or a total area of this rectangle must be equal to 40 square units. And that is the answer to our question. Therefore, given this figure, the area of the rectangle must be equal to 40 square units. And as always, we are done.